Hello everyone, my name is Willem Zohar, and this is a short presentation of our collaborative paper, Neural Machine Translation Quality and Post-Editing Performance. When one submits a document for translation to a company, most often nowadays it is not translated by human translators from scratch. Instead, the document is first translated by a machine translation system, and then the professional translators, who we call post-editors, use this as a basis and either rewrite the suggested translation or only make edits. Afterwards, the documents are sometimes reviewed by another set of professionals, who we call reviewers, and the translation is finalized. Because the NMT system is the first step in this pipeline, we want to examine how its performance affects the required effort of the post-editors and the reviewers. This research can be of particular interest to translation companies because it can help in deciding that the further investments in improving the NMT system performance will be offset by the hopefully shorter post-editing times. Our research aims to replicate the whole pipeline to evaluate the strength of the relationship between the NMT quality, the post-editing speed, and the final translation quality. Intuitively, one would think that the higher the NMT quality, the lower the number of mistakes the post-editor has to fix, and hence lower time spent on the translation. Later, we'll see that this intuition is unfortunately not confirmed by our results. Our setup is as follows. We select 8 documents in English, which we translate by 13 NMT systems to check. These NMT systems have intentionally not the best performances. Their distribution, ranging from 25 to 37 blast scores, is in the table on the right. This creates 13 translations of each document. To this, we add the document source in English and also a professional translation into Czech. This overall yields 15 versions of 8 documents. We give them to 15 different post-editors who use their standard setups to improve these translations. We do not inform them about what level of NMT quality documents were translated by, or whether it was translated already by a professional. Finally, their outputs are given to reviewers together with the reference translation and translation by our best performing NMT system from the first phase. Overall, 17 different translations of all documents. In 2016, Marina Sanchez-Torron and Koehn did closely related research with a similar setup. There are, however, very important differences that influence the results. The key difference is that they use phrase-based NMT, while we focus on the current state of the art, which is neural NMT. This is an important distinction because neural NMT outputs tend to be very fluent, even at the cost of adequacy, which may make the post-editing cognitively more difficult. Another distinction is that the NMT models they used were evenly distributed in the 25 to 30 BLA range, while they focus mostly on the best performing models. This is motivated by the fact that most translation companies won't be making a decision between using an NMT system that has 25 BLA score versus one which scored 35 points. Instead, the actual differences will be more minuscule. The last distinction point is that we use 2 phases, post-editing and reviewing. This is useful for us to estimate the produced translation quality. Their results were quite positive. They found a linear relationship. 1 point increase in BLA led to a decrease in time spent on a word by 0.16 seconds. Time per word is usually used because the pricing of translation is commonly based on the word count. The first thing we examine is simply the degree of similarity between the NMT output, P0, post-edited translations, P1, and reviewed translations, P2. Both the table and the figure show the same statistics, but in different views. For measuring similarities between sentences, we use character engram F-score, but when using TER, we saw similar results. For the first phase, which is also depicted in the graph, we see that 1 point improvement in BLA leads overall to 1% more similarity between the NMT output and the post-edited version. For the difference between the first and the second phase, this relationship is almost non-existent. Overall, the second phase had much fewer edits, suggesting diminishing results of further phases. There are a few outliers, namely translating from scratch, which is edited more on average and also in the second phase, and when reference is provided to the post editors and reviewers. They edit it much less, even if they are not informed that it was previously translated by a human professional and not an MT system. Secondly, we explored post-editing times, which is more indicative of the effort and is more interesting from the commercial perspective. Here we encountered an issue with the recorded times because they contained a lot of noise, presumably when the post-editor switched tasks even though we instructed them not to do that. We therefore applied a simple albeit important heuristic to remove this noise. It is based on the two quantities to which we have access to: think time, which is the delay between seeing the sentence and the first key press, and the total time between seeing the sentence and submitting it. Again, the figure and the table show the same statistic, but in different views. In contrast to the similarities between phases on the previous slide, the effect of MT quality on post-editing time seems to be much lower. This is in contrast to the finding for phrase-based MT by Marina Sanchez-Torron and Koehn. We only find a peak relationship between the top 8 systems in the form that one extra delay point corresponds to 0.51 fewer seconds spent on word on average. It is important to note that we had 8 documents per one MT system, and each of these documents was post-edited by a different post-editor. This way we hope to average out the influence of individual differences among post-editors. The differences in the conclusion from the previous work may then be explained mostly by the differences between the quality of the MTs used, the fact that we used neural MT, and also the noise. Finally, we examined the second phase. From the perspective of spent time, there seems to be no relationship between the MT quality and the reviewing effort. Exceptions to this are the reference translation and the translation from the system M11, in which we provided the reviewers with unpost-edited versions. They are marked with an asterisk, and for those the reviewing took longer. The reviewers also used an annotation scheme for errors based on LQA. They each had an assigned category: adequacy, fluency, or other. They also had a severity score from 0, least severe, to 3, most severe. We see that there were differences between the specific domains of the documents. The news domain specifically was edited much more than the others. For the MT systems, we did not find any noticeable linear relationship between the MT quality and the number of severities of the errors in the second phase. Again, exceptions to this were the unpost-edited reference and M11 output. I would like to conclude with a reiteration of the most important findings in this big information dump. The biggest finding is that even though we found a weak relationship between the top 8 most performant systems, we did not confirm this trend across all models. The takeaway from this is that for modern neural MT systems, the relationship is probably weaker than for phrase-based MTs, and that we should not expect small improvements in MT quality to lead to much lower post-editing times, nor higher final quality. Another interesting observation was that even though post-editing is now a well-established part of the whole professional translation pipeline, it was only marginally slower than the average when post-editing MT outputs. In comparison, post-editing a reference, even when the post-editors think it's an MT output, had the lowest post-editing time and the least number of edits. Regarding the second phase, when the reviewers examined the post-editor's output and made further changes, they took 60% of the time but made much fewer changes in the text overall. Apart from the case where we provided them with unpost-edited translations, that is, raw MT output, there was no noticeable effect of MT quality on times nor the number of edits. Thank you everyone for listening to this presentation. All the data and source is available online, and I'll be more than happy to answer any questions either live, via chat, or email.